Hello, good morning and welcome to this interactive session. Last week we did look at the structure of the earth and the rocks, and I have shared a small video explaining the structure of the earth, so I hope you will find time and view it. Please, when you're watching those videos, don't just watch them like you're watching television. Those are education videos, so be careful, take notes out of those videos, make notes. If you have any comments, put them down so that when we meet for the interactive session, you are able to ask what you watched in the video and that did not come out properly to you. You might have taken note of that. Now, moving on today, I want us to look at continental drifting, plate tectonism, and the seafloor spreading theories. Once again, I must mention that I've shared the videos on this specific topic. There's one on continental drifting, there's one on plate tectonism, there's one which also explains seafloor spreading. So take time and watch those videos very well. But what I'm going to give you is just a short-term explanation, because those of you who attended the webinar, I did explain for a long period of an hour. Those of you who had issues with network, take this explanation quite shortened, and then also view the YouTube videos that I've shared with you, so that you are able to ascertain and also read the notes, and then any other reading materials, you'll be able to understand this entire topic. So the continental drifting theory, of course, was put forward by a German scholar known as Alfred Wegener. Alfred Wegener was a climatologist who, after looking at the shape of continents, realized that there was a likelihood that these continents were once together, were once one landmass, and further examination made him to make a conclusion that at one time T, there existed only one landmass known as Pangaea, which was surrounded by one water body known as the Pansalansa Sea. And then, of course, one thing that we shall note that Wegener goes ahead to assert that Pangaea broke down into two supercontinents known as Laurentia and Gondwana, whereby Laurentia was in the northern hemisphere and Gondwana in the southern hemisphere. The problem here is that Wegener does not explain the force behind this split of Pangaea, and that's what other theories like plate tectonism comes up to explain. That's what plate tectonism comes up to explain, because Wegener did not bring out the explanation, did not account for this breakdown. Nonetheless, he says that between Gondwana and Laurentia there was a small sea, a water body known as the Sea of Tay. But then he says that further, these supercontinents broke down to form the southern continents, for example, Gondwana, and then Laurentia, the northern continents, respectively. He concluded that the continued continental movement formed the geographic pattern of land masses that exists today. However, Wegener would have remained just a speculator if he had not given evidence of these assertions. So Wegener went ahead, not necessarily during his time, but even up years later, certain geologists in the 1950s and 60s came up and explained, even because he had, by this time, after the First or Second World War, the science had grown, people had many ways of ascertaining knowledge and collecting it. So a lot of evidences were put forward to explain or to support the continental drifting theory. The very first one is the initial evidence of jigsaw fit, that when these continents are brought together, they would fit into one another. That's what Wegener was talking about. Watch the videos that I've shared there to try and explain this thing of the puzzle, that South America and Africa would fit into one another, that Europe, Eurasia, and North America would fit into one another. That's what we mean by the jigsaw fit evidence. Like it's explained here in this illustration here, when you bring them together, you see how Africa and North and South America are fitting. And then of course below here, this what this the illustration lacks. Below here we have Australia or Antarctica is here somewhere in this space here, joins up here. So at the end of the day, you find that this one here eventually becomes one landmass that Wegener once did mention that it was known as Pangaea. Of course, we have the concept of mountain ranges on opposite sides, which also have exhibited similar pattern. Mountain ranges on similar sides. Again, from this illustration, we see this yellow here, this yellow painting here. It shows that the nature, there's matching ancient assemblages. For example, rocks and mountains, they have similar pattern. We know very well here we have the fold mountains. We have fold mountains here. We have fold mountains here. We have fold mountains here. All these ones match. So when someone looks at this, would be able to conclude that maybe one time T, this was just one landmass. I gave you the example for when I was doing the webinar that when you look at Uganda here, you go to Busia, you will find Samias in Busia, but across the border you find Samias in Kenya. You go to Namisindo, you find Bagisu. Across the border you find Bagisu. You go to Karamoja, you find the Karamoja. And across the other side you find there people speak the similar language. The same with the Bakonzo in Western Uganda. The same with the Bachiga. So you realize that after the colonists came and split this one huge landmass into different geographical units, what we call countries, then you have people going into different places. But the evidence here is that most likely it suggests when you find Samias in Kenya and Samias in Uganda, it suggests that at one time these people were one community. It's the effect of colonialism which forced them to go into different places, the splitting, and that's what Wegener does talk about. He talks about the similar patterns of fossils and rock types, that when you study the fossils in West Africa and fossils in Eastern Brazil, you are able to ascertain that there is a similarity. Fossil here, looking at the remains of ancient rocks, remains of ancient crops, remains of ancient animals, there was similarity established there. He also cited the evidence of great climate change. It does say that there is evidence of glaciation where Sahara Desert is today. There is evidence of tropical fossils in Antarctica. In Antarctica, these are polar regions. So if you found there a fossil of a cedar tree or mavule tree or mahogany, what would be your conclusion? That one time mahogany grew in Antarctica, or one time Antarctica was somewhere in the tropics, but just drifted to where it is today. That's what Wegener is talking about here. We have existence of abundant oil reserves in the desert areas, like in North African Sahara. We know very well that oil or petroleum is a sedimentary rock of organic origin, basically organically formed sedimentary rock of plant and animal origin. And we know very well that deserts are barren lands. So then where did these fossils come from to create the fossil oil? So Wegener does mention that most likely present-day Sahara Desert was somewhere below, closer to the equator, where it had abundant life. And then when it drifted northwards, these fossils were turned into petroleum. Of course, there are several other evidences, like the fauna and flora, the animals and plants found in these continents. There is a match. The tropical rainforest in the Congo Basin, the tropical rainforest in the Amazon, the tropical rainforest in Malaysia and Kalimantan, that island of Indonesian island of Kalimantan, Indonesian island of Sumatra, Malaysian island of Kalimantan, Borneo, that entire place. In its Philippines, they are similar. So someone Wegener was right to say that probably this was one landmass, but just split. Then we move on and we look at plate tectonism. Plate tectonics here looks at it. This one now is the difference between plate tectonics and Alfred Wegener, that for it gives us the evidence, the force behind the split and movement of continents. Because Alfred Wegener did not give the force behind it. Alfred Wegener just made assertions that the Pangaea split into Gondwanaland and Lawrence. that Laurentia split into Europe, Asia, and America. But he did not give the explanation. So plate tectonism goes ahead to give us the explanation that the Earth is broken up into 12 rigid plates. When you watch the small video shared about the structure of the Earth, it shows you how the Earth, the crust is the rigid plate. These rigid plates are both continental and oceanic. Of course, you know that the oceanic crust is in terms of width is narrower, whereas the continental crust in terms of width is wider. Part of the oceanic crust is covered with water, is occupied with water. That's why it's narrow. But we know very well that the oceanic crust is denser than the continental crust. So these rigid 12 plates slide over a semi-molten layer of mantle. You look at the video of the structure of the Earth, we know that the mantle is molten fluid. So at the end of the day, because they slide over this molten mantle, then they develop what we call plate boundaries. Again, I've shared a video on plate boundaries. Please watch it up to the end and with keen interest. Take down notes out of it. There's a lot of information in it. So these plate boundaries are either spreading or what we call divergent, where plates are moving apart. And these ones are caused as a result of convective currents that move in divergent direction, or what we refer to as tension forces. The transform boundaries, these are the ones where plates move past each other. Then we have the convergent or subduction boundaries, where plates override one another. These ones are convective currents moving in the same direction, moving together from different directions, but moving together. In other words, they are converging. And we know that when there is convergence, then there is compression. So these three plate boundaries define a lot of things. As we know, when it comes to landform evolution, landforms form along these plate boundaries because that's where the action is. If plates are moving divergently, where they are moving away from, that's where the action is. That space must be filled up. If the plates are moving convergently, that's where the action is. Where these two plates are meeting, that plate boundary is where the action is. So they are very important as far as landform evolution is concerned. We know well that each plate is bounded by what we have, the oceanic crust and the continental crust. The driving force, this is what Alfred Wegener did not mention. The driving force in plate tectonism are the slow-moving convection currents in the underlying plastic mantle material. We already mentioned that the mantle is fluid and molten and hot and mobile. So the mobility of the mantle generates some kind of a current. These convective currents, when we talk about current, I want you to look at a water current. When you blow over the surface of water, the water begins to move. In vernacular, they call it amayengo. It begins to move. That current can move to the side of the lake. That current can move to the center of the lake. It can be divergent. It can be convergent. And so plate tectonism has mentioned to us that this is the force behind the movement of continents. This is the force behind the splitting of continents. Those slow-moving convective currents. They seem too slow, and even when we explain it, it looks too trivial. But in a real sense, these convection currents do cause a lot of action within the interior of the Earth. Then what is the evidence for plate tectonism? We know even under plate tectonism, they came up with certain evidence to help us understand, is it true? Did this happen? So they came up with certain evidence to help us understand the plate tectonic theory. The earliest of them is the one which was given under continental drift, is the issue of the jigsaw fit, the shape of continents, that when you bring them together, they will fit into one another. They will talk about the issue of the type of rocks and the edges of fossils on either side of the Atlantic, which matched when the two continents were put together. So the jigsaw fit issue comes in. Then we have the edges of rocks and fossil evidence, which is also matched across continents. All this information is explained in those videos I've shared with you in detail. We have earthquake patterns. I already told that earthquakes, those of you who attended the webinar, earthquakes I told you action is at plate boundaries, where where two plates meet. That's where the action is. Is it a transform fault, a transform boundary where plates are moving past one another, or is it a convergent boundary where plates are moving towards one another? Is it divergent? And we know that earthquakes form when plates collide, when tectonic plates collide. So it's not a coincidence that earthquakes are common in Southeast Asia, that earthquakes are common in Southern Europe, that earthquakes are common in somewhere close, somewhere in the Pacific, in these Pacific islands, the Atlantic islands, somewhere there in these areas of Haiti, that area, Latin America. It's not a coincidence that they are common there. These earthquake patterns do confirm to us that there exists plate boundaries, and along those plate boundaries there is action taking place. Land masses are moving. We have volcano patterns, and under volcano patterns, I'll give you the example of the mid-Atlantic ridge. You know the mid-Atlantic ridge, which stretches over 10,000 kilometers. I think it's over 10,000, if not 100,000. It's quite a long, all the way from the Atlantic, North Atlantic to Southern Atlantic. And along that mid-Atlantic ridge is a series of volcanoes occurring within the ocean. And why in that exact place? Because this mid-Atlantic ridge explains the seafloor spreading. And seafloor spreading, how does it come about? Seafloor spreading happens when the divergent plates move apart. An oceanic plate moves. Two oceanic plates moves. For example, we have the Atlantic and the East Atlantic and West Atlantic. They move. The gap left behind is filled by the molten rock to come and cover it up. And we know well that the extrusion of molten rock onto the surface or into the surface of the earth is what we call volcanics, and leaves formation of volcanic mountains. So these volcano patterns, I give you the example of East Africa here. We have our volcanoes in Uganda, eastern border, in East Uganda, western border, in Kenya, they're in the middle. That's where we find those volcanoes. We look at Kilimanjaro, Mount Kenya, they are just somewhere in the middle, not at the coast, because they are shaded, they have a specific pattern. The existence of that Rift Valley does explain why those volcanoes are formed in those areas. We know very well that when the Rift Valley was being formed and the central block was subsiding to maintain equilibrium, there was displacement of material within the Earth's mantle, and pressure and heat. So that material which was displaced eventually could not hold its capacity. The carrying capacity of the overlying layers was overtaken. So the material made its way out onto the surface of the Earth, forming those volcanoes. That's why you have the Oregons, you have the Kenyas. In between, there's a Rift Valley. Those volcanic patterns are also evidence to suggest that continental drifting and plate tectonism does happen. So that's what I wanted to tell you for today. Quite short video, a short recording, but watch the YouTube videos I've shared because they have all the other information, and take keen interest, please, when you are watching it. I have also noticed that a lot of you struggle with Moodle, but I was talking to your friends and they told me that they load the Airtel data for 600 shillings and we are able to last for a full hour. So and they are better off because they have a better connectivity. So I would advise, if you can part with 600 shillings, get a data bundle of Airtel, depending on the network, which network is stable in your location. Because some of us, we live in areas where MTN is better. If it's MTN, you need 1,000 shillings for 100 MBs. Some people, it's Airtel, which is better. So acquire that small bundle and you are able to follow during the interactive session so that you're not left behind. Some others are complaining about not being able to do the first exercise. That was just the first exercise. More work is going to come. Remember, we are going to have more take-home assignments, more this work here than may even account for more marks than the final exam. So I'm going to give you more work as we go by. In fact, before the end of this week, there's going to be more work for you, which you should be able to attempt and submit. I want to thank you for those of you who endeavor to attend every Thursday. I pray that you are able to continue doing this and you are able to understand. Please, if you have any issues which arise out of this that you do not understand, probably sometimes I'm too fast. This is just a recording. It's not a like class where I'm able to get feedback from people and I pause. Take note them down. When we meet for the live session, those are the first things you must raise even before we begin anything else. I want to thank you so much, and God bless you.